So Alex, you must be in London?
That is correct.
And is Fact Technology a division in Imperial College or?
No, so we're not so much a spin out as a spin in. So I set up my own company separately, but I teach the mechanics of composite materials course in the mechanical engineering department there with one of my researchers. So I'm a lecturer in composite materials at Imperial. Most of the time I'm running my company.
Which is Fact Technology. Okay.
Correct.
Whew. Hey, everybody. Oh, there we are.
Okay, so good. There's only, oh, I thought there was only like 3 people.
Hello, everybody.
There's only 3 people. We have like right now, I think 48, and
Okay,
it's growing.
That's better.
So yeah, it's a little bit better, right?
Yeah.
Yeah. So we'll set things up here. So, well, hi everybody. I think we'll just let a few minutes go by, or I mean not minutes, but we'll let a minute or two. And we'll let everybody sort of gather. When that number stops really rising, we'll kick it off. Man, we got like a big turnout today.
Looks like sustainability, it's on a hot topic today.
Yeah, that's a good thing. Let's not do what the wind turbine aerospace guys did. Be like, oh, we'll kick the can down the road for 30 years. And then be like, oh, this is a problem.
You know, it's actually that kind. Yeah, it's exactly those kinds of things. Like, let's start talking about the ugly facts right now. You know, that's why I find it kind of exciting. Although it's nice to talk about ugly facts, particularly if you have a, how should I say, a horse in a race and you're racing against someone else, right? So that was actually, by the way, the whole spirit behind us wanting to do this is that in this day and age, information, whether it's good information or bad information, or the analysis, whether it's good or bad against the information, it moves fast. And I think every day, right? Every day you go to work, it's trying to figure out what it actually means. And that was a little bit of the talk, when I was talking to Yen, the other coordinators, about, well, some of the things that I see day to day. What are the great challenges that I have? What are the things that we'd like to talk about? And this one actually popped up, and it's not so much the sustainability part as is the misperceptions part. And when I say misperceptions, we'll get into it, and I'll probably start sharing something here in a sec here. But the whole idea of there are a lot of interpretations out to what these analyses mean, or how they are being vetted, or how they're being utilized by various stakeholders or so on. And so, I thought we would actually have a little bit of fun on going through some of that stuff. So I'm actually going to share a little bit of screen on the splash, and hopefully we can see that. You should be able to see my splash screen at this point in time. Tell me if you can.
Yes,
Yeah,
I was hoping that if you could incorporate some information about the needs on the lithium ion batteries, you will be my hero.
The knees. Yeah, we have actually, there's an entire session on that one. That's another work group that's covering.
Right, I had to choose, so I chose this one, hoping that I could get a 2 for 1.
Oh, okay. Well, let's see if we can bring that topic up. Maybe we got enough time to do that. That's an interesting one too, eh? Yeah. So, oh, by the way, I sent it out in the chat box. If there's anybody here that's willing to open up and take the notes, I would greatly appreciate it. I will have absolutely no problem at all afterwards of sharing the slides that I have here. Nothing, there's nothing here that's earth shattering or secret. In fact, that's the whole point of this thing, right? Is to be very open. But if anyone can take some notes, because I'm sure that everybody here is going to bring up some really awesome topics as we go ahead. So that's the fun stuff. Okay. All right. So you can see the screen. I'm going to go to the next comment because I want to steer this, and let's just open it up, because this is going to be and remember, we're always going to have a little bit of how should I say, group interaction here on this one. So first of all, we often hear, well, are green cars really green? What does green mean? So this is the first topic that we often get about is, well, what is the interpretation of green? And it all depends who you're talking to. And usually when we talk about electric vehicles, it's, oh, look, I'm using electricity, so I'm not emitting anything. Well, okay, that's perhaps true. There's no tailpipe that's emitting, but you are using energy and you're consuming it, right, to do something. So therefore, that's important. Where does that energy come from? So the classic one that I get a lot of, the colloquial one, is, okay, but the grid is very, very dirty. So they're actually dirtier than gasoline cars, aren't they? And so you get a lot, and I think many of us who see all the memes and so on that indicate that. So obviously there's a lot of people which will argue, no. Once you get into it, the emissions are worse for electrified vehicles, particularly battery electrics. Oh, and it gets really, really bad when we talk about all the energy that's consumed on making the batteries themselves, and particularly when you talk about the critical minerals and how destructive it is to mine these. And so you get into this entire discussion about where the minerals are coming from, the ethics that are associated with that, the damage that they do to their ecosystems. And I think many of us, and this is going to be a great topic, whenever anyone want to bring this up, this is again something I'd encourage, is this idea of how we'll call it ecological justice and equality and equity, right? Anybody who's been reading, for example, in the United States, the documents, the policies that are being generated, particularly including, for example, the IRA, this actually factors in pretty big as being one of the themes, being very central to it. So it's interesting, that we're in a budding new industry where we're going to suddenly have to, instead of drawing gases or liquids out of the earth, we're moving earth to get earth, right? Which is, when you think about that, that's far more visceral than, to the average person if they see, a mountain moved, which, anecdotal to cold. Let's think of that. So if you think of those images, that's again, right away people think about, the use of land and the justice associated there. And I'd love to hear anyone else got any kinds of phrases they've been hearing, where there's accusations thrown, obviously, against electrified vehicles, against the entire industry. Throw them out. Feel free.
Well, there's still that people are, which hi Oliver. People still
Hey,
think
Ann.
we're gonna run out of lithium. Somebody wrote something a while back. We're gonna run out of lithium. We're gonna run out of nickel. No, sorry, not the case. All cobalt is small little kids in the Democratic Republic of Congo, languishing and at quote unquote artisanal mines. So there's a lot of that still rolls around, which is like so not true. But anyway.
But those are examples. Those are examples here. Gia just put one in the chat box. I'm monitoring the chat box, folks, too. Okay. Lithium battery recyclers, are they really recycling, or are they just stopping at black mass? In other words, they extract a little bit. They're very inefficient. Hey, this is a great point. But I mean, this is not just about recycling, this talk, although you could have a huge series of talks about it, right? About the efficiency associated of just the actual conversion, extracting what out, what about the energy that goes into that? What about, we're not even talking cost here, folks. We're just talking energy, and what's good for the, when we talk sustainability, what's good for the world, Second one, Second Life, is it really doable, right? How does that fit in the circular economy, right? So those kinds of things, great topics. They're all hot topics, and I think that they're all legitimate points when we start talking about sustainability. The one thing I made a point in all the discussions that I'm doing. Oh, by the way, there's one of my hot topics in the last month, PFAS. The thing is, we could talk about life cycle assessment, analysis, and circular economy. I'm not going to get into like the great details of the models, but I think that's where we are heading in this sort of thing. So I wanted to just go through a little thought process just to put some things together. Some of the numbers, typically when you want to geek out as an engineer, you always want to run after some numbers. And when I deal and I happen to work for a car
sorry, Oliver, sorry to interrupt, but I just wanted to add two more that I think are important.
Go ahead. Go
One
ahead.
is, thank you. One is the displacement of people, often indigenous people, and often forcefully in terrestrial mines. It's something that I think is not talked much about, but it's the kind of dirty little secret that nearly all mines have to displace people to build their infrastructure, to build their highway, to build their village. And that is often indigenous people who originally owned the land, but unfortunately these days don't seem to have as many rights. And then the second is water usage. A lot of this refining technology uses huge amounts of water, and often in areas where water is very scarce. Thank you.
Excellent point. Thank you very much for that one. You know, it's interesting. And this shouldn't be new to us, these kinds of things. You build a reservoir behind a dam. Think about the impact there. Again, different than necessarily drilling for oil, right? It's again hidden, even though the impacts are quite dramatic, as we all know, but they're different. And understanding those differences becomes important, right? So when I was going to talk a little bit about some of the numbers and so on, I just threw some numbers here on a screen. Just this is the classic play. You get this out of a textbook. But if you think about, for example, how much energy typically is produced or consumed, I should say, for the production of a battery, depending upon where you are in the scenarios, it's a range like anything else. Typically today, it's somewhere between 60 and 100 kilograms of CO2, greenhouse gas, that would be generated per kilowatt hour of a battery. And again, we can look into the variation depending on where you're building the battery, what materials go into, and those are sort of the typical numbers. If you look at the US grid in terms of what it produces, a kilowatt hour of electricity generates about 575 grams of carbon dioxide. And again, this is on average. This is across the entire country. We all know that here, like many other countries, it depends regionally where you are, also time of day, season, etc. That there are variations. It could greatly exceed that number. It could be quite a bit lower than that number. But if you were to average that out, that's typically what you're looking at. And so what I'm doing in my case here is I'm saying, okay, if you typically take about an EV that does about 275 watt-hour per mile of energy consumption, it means that's roughly then equivalent to about 158 grams of carbon dioxide based upon that per mile. And if you turn that to an internal combustion vehicle, which does say about 20 miles per gallon, roughly in the same size, it's about 381 grams per CO2 per mile. So you look at the difference between the two, it's about 223 grams. And so what that basically means, just to account for the additional CO2 that's been generated and the energy consumed for the battery, you need to drive that vehicle about 30 to 45,000 miles before you break even. So starting off with just the carbon dioxide side, yeah.
Are you backing up though and looking at how much CO2 is generated to extract and refine the gasoline and deliver it to the pump?
Interestingly enough, no, because if you take that into account, then you find out that number actually is going to get about half.
Right. Yeah. 'Cause I've done stuff that we look at wheel to well, but this is interesting. But anyway,
But that's exactly where I want to take the conversation.
Okay.
Is exactly that, is that even 30 to 45,000 miles, and this is what the great objection that we get. And I'm happy you brought that up, Anne, because then what can someone do? Well, someone can say, okay, well, I'm going to take this analysis and I'm going to ignore, the energy consumed to pump the crude, right? To first get it, to refine it, to transport it, to store it, to distribute it, right? Just ignore that. Oh, and let's talk about, coal-fired plants on a very inefficient grid. Let's put that in there. And you can start converting it and make that number grow, right? You can do all those sorts of games. But at the end of the day, what I wanted to do here was just to give people an idea. One of the great arguments is that because there is energy consumed in the production of a battery, that means that the vehicle has to have some use before it actually can reach equity with its IC partner, and then it crosses over and it's more efficient. But as we move on, right, as we find out that we need to put more effort and energy into, let's say, one of the fuels versus the other, that's that gap can actually narrow. And I think that that's one thing to think about. So let's keep that in mind, because the next slide that I've got talks a lot about this. And I think this is actually a pretty fun slide. So this is cradle to grave, not cradle to cradle, okay? Cradle to grave is where you build a product, you use it, and then at the end of its life, it's over. It's dispositioned some way. So we're not talking about the dispositioning. We're not talking about the recycling. US Drive, which is a consortium within the United States, it's actually made up from US CAR, the US Center for Automotive Research, combined with participants from the utilities, energy companies, and actually recently now there's new partners that will be coming in from various materials companies and the like. But this study here was done by Argonne National Labs using the GREET model, and they do this model, they refine it every couple of years. That, you know, new inputs and new discoveries. So this one was just recently issued publicly, about I think about a week and a half ago. And just to give you an idea of the kinds of studies that they do, is that they will look at various kinds of technologies and various kinds of fuels. We'll use the term fuel here, okay? And they look at different kinds of possible scenarios whereby those technologies could be enabled in certain points, and look at the greenhouse gas emissions. And so the GREET model is quite effective at that. By some people it's considered the gold standard. I think, you know, anyone who works in the field, there's always criticisms against any kind of model, right? They're all wrong, just some are useful. And you get into this analysis that's to the right of it, which looks at the various kinds of technologies. And what you can see as you walk across is that first and foremost, the greenhouse gas emissions and CO2 per mile for when you deal with gasoline is pretty much the highest, and we would expect that. And here they are taking the entire well to wheels type of analysis into account. That's why these numbers will look different than what I gave. So interesting, what I found here was that, first of all, gasoline was the highest. However, what you notice in here, and I'm just using that as the start, and then we can walk across, is you can see that if you do the various kinds of supplanting of the conventional fuel, you can reduce the CO2 emissions by a dramatic amount. And so just going through how this analysis works, right? The black bar is basically where you are today. The red bar is basically where, if you take future technologies with base fuel, in this case, this would be gasoline, you can see this degree of improvement. Anything beyond that requires these future technology cases, and the bottom of the arrows are about as low as they can get. What they also do, the blue bars, is essentially the input of the technology. So in other words, it's essentially the energy that's consumed to produce the vehicle, and they're all in nominal vehicles. So you can compare the blues, and they roughly give you an idea of that energy if you normalized it over the life of the vehicle. In this case, I'm pretty sure they're using about a 200,000 mile total life estimate. And of course, if you change that number, okay, the bars move, but the proportions are all the same. So you can see that there's a lot of improvement that could be made in all of these cases as you go through the different kinds of propulsion systems. But going in with today's technology, what was really fascinating is that the battery electric vehicle has improved as much as it has. Because if you look at this study that was around, say, 6 years ago, those bars would not have been there. They would have been quite a bit higher, actually. That was actually the shocker that I saw with this most recent GREET model, is that the battery electric vehicles have improved as much as they have. Because actually, in the past, the hybrid electric vehicle bar was quite impressive, and the batteries made even the PHEV quite a bit worse. So the simple fact that the model has had to improve itself simply because of the improvements that we've been seeing in the technologies, in the industries and so on tells us that these studies, yeah, they do need to be quite frequently revisited. It still paints a pretty rosy picture for many of the technologies, particularly with the battery electrics, with regards to how low that they can actually go. And the size of the battery and how it influences here is pretty interesting. So I think the other thing you take away from these kinds of analyses is that there's a lot of improvement that's potential across the entire board with regards to a lot of these technologies. However, just because you can do it doesn't necessarily mean you should. And that's the other part of sustainability, right? Is just because we can produce a lower CO2 response, there's other things that we should be thinking about. And I want to re-emphasize here, materials recycling was not taken into account in this model. I think there are other models I think many of us are familiar with that are being looked at in order to capture those kinds of models, particularly in the battery space. And it would be interesting to see a follow-on study which looks at the what-if scenarios here if that recycling were to play out with those types of scenarios. Again, the goal here was not to necessarily look at all that.
So, and so
Go
if
ahead.
quick question. So if I understand where the arrow is of the gray is only as far as they think it could get to, and the blue is where, because I mean, a BEV, what they're saying is like a 400 range battery electric is no different if you're, and of course this is like who's capturing this carbon anyway, or if it's wind, solar, and that I notice on the hydrogen side of it, they've got steam methane reform, so they've got gray hydrogen, but they're assuming, well, they've got blue hydrogen, so they're not really looking at how hydrogen is produced today. So it's a little, I'll have to go look at, I'll have to go Google it and look at it.
Go ahead and have a look at it. What it is that there's certain scenarios in the future technology cases.
So they're looking at, right, they're saying.
Right, they're not looking at the current technology cases. The current technology cases are tried and true, they're the black bars. And they can go to the red with certain improvements.
Because even on the fuel side, they're assuming e-fuels, and on the diesel, it's all renewable.
Yes.
So they're not looking at the current state at all.
So what's pretty interesting here is the amount of improvement that some of these future technology cases can potentially make and close the gap. So that there is actually one of the fascinating parts. Now, the truth of the matter is, and I can see that with some of the chat in the chat box, yeah, the idea of what it would take to make any one of these bars possible may in and of itself be almost a near impossibility. And so that's one of the questions that you always have to ask with these technologies. It's great in the scenario that's being put here, but is it even, when you start getting into it, is it truly feasible? But so this simply again gives you that that ability to start asking those questions.
So one really interesting thing is a lot of this is about essentially bio-derived fuels. So plants have taken CO2 out of the atmosphere, created bio-derived fuel. A question that actually aerospace primes and tier ones are really struggling with is what happens if rather than using a petroleum-based feedstock chemical, you use a bio-based feedstock chemical, i.e. CO2 is embedded in the molecular structure of your plastic part or your composite part. Is there actually a case in that instance that actually that's carbon capture, so you don't want to recycle it? And this is becoming a real challenge where I've never seen engineers go, you know what we need? More accountants, because we actually do not know how to account for embedding CO2 in a physical product by using a essentially biodiesel, crudely speaking, versus regular diesel as a feedstock for plastics and composites.
And that's an excellent, by the way, that's an excellent topic on plastics and their life cycle too. I know we're not covering that here, but that's actually one which I find quite interesting too. Like the idea of single-use materials. Well, yeah, the single-use materials, then what you're basically saying is I just want to release all the CO2 that I just put into the material itself. And it gets worse actually when you get into durable materials, because then you have to look at the energy that you've invested in it versus the energy you can release. By the way,
I would like also to open another topic because
yeah, go ahead.
We are forgetting completely the world around the car. For example, in the tunnels, ICA cars need fans to get the gas out of the tunnel. and the electric car don't need this. So they are saving another source of energy. For example, in the tunnel, you don't need the ventilation for electric cars. And this,
There's
for
actually,
example,
but
in Italy,
there's another emission that you need to worry about, right?
the
PM
movement of
2.5
the
from the
car.
tires.
Thank you. That was exactly the one I was going to bring up, is PM 2.5, which I think is another emerging emission. And because I may hop ahead. If you guys are okay, I can hop around the slides. I'm happy to do this because again, the intent here is to be open. But one of the things is that sustainability isn't just about CO2. I wanted to bring that. We know how important greenhouse gas mitigation is. I don't question that here, right? But we also need to think in mind that as we pursue greenhouse gas, we have to take into account the others. Case in point, the ozone layer concern, right? Ozone depleting agents, we tackle them. We replaced ozone depleting agents in a lot of our HVAC systems with HCFCs, only now to find out that those things are about 3,000 times more capable of absorbing heat than the materials they replaced. So now we have another problem. So this idea, this thought is to get ahead. So that's why I brought that up. But I agree, Simone, with the idea that if you get rid of emissions of one, you don't have to deal with that emission, right? You know, so and that's always of a benefit, because
Yes, and
this one
for
feeds back
example,
well.
For example, in this slide, I would also like to add acoustic emission and heat emission, because, for example, in the summer in the city, if you go around by bike, if you are surrounded by very hot petrol cars, it's completely different than colder electric cars.
That's an excellent point. So if you look at we engineering our surroundings, right now we have to do engineering for all of the emissions that come off of cars. Acoustics, that's a good one. And thermal, yeah. So those are other items that we have to think about when we go through this as well, just from the engineering of the surroundings itself. And also, by the way, that also speaks to a lot of the equity and justice topics too, I think, because very often we find where these particular vehicles are and the cost of then doing that, it may be deferred to those areas that seem to be more amenable to take them than others. So the short list, why I brought this up here, and I saw a lot of topics being brought around, and this is now to look at the terms in greater view of what sustainability means. If you take an ICE vehicle, I think we're coming down to the point where we have a lot of emissions that we got to deal with, and we're good at some, not so good at others, right? And we should learn from the judicious management of those emissions on those vehicles, particularly as we move into an electrified future. While the greenhouse gas argument, I think we can go back and forth, and it's pretty clear that the pathway is always going to be better if you electrify versus utilizing essentially petroleum-derived types of fuels today. We also have to take into account the other kinds of emissions, and this applies for all of them. The one topic it was brought up earlier about using biosourced fuels. Biosourced fuels have their own challenges, right? They have their challenges that they are taking away from land that could be used elsewhere for other things, be for human or non-human purposes. They also have significant impacts on water usage. Eutrophication is another one. I always have a problem with that word. And as well as other kinds of direct impacts. I think you saw a few people bring up some of the more recent topics, such as fluorine compounds, forever chemicals, PFAS, which is in batteries right now. It is a material. There are materials that we use that fall into those categories, and depending upon the chemistries, we may need more of them. So the question is, does it make sense to have a material that will be able to be recyclable or recoverable and utilize this advantage of being forever, or is it still considered to be too high of a hazard that we wouldn't do it? We're not at that point yet, but those are thoughts that we think about now that historically we wouldn't even have bothered to until it's much further down the pathway. I think the PM 2.5 is another good example. I think it's becoming pretty clear that air quality is a very significant health concern around the world and getting worse, with PM 2.5 being one of the major contributors. So we may solve a lot of the other emissions problems, but that one's still there. So again, I'm happy. Anyone else want to share some of their thoughts, their ideas, in this area, their experiences? Feel free. This is the one of the better parts of the talk here, to think about ideas of where our real challenges are. Is there something that electrification is bringing up that is going to notably be a terrific concern compared to what it's replacing? In other words, it's a threat that we didn't have until EVs came along.
I would just add that I put in the chat, there's a website that we sustainability goals that I think need. Obviously, CO2 emissions is one, but I think there are 7 others that are very, very critical. And I think
I think that connection was a bit tough there. So
I couldn't hear any of that.
Okay.
Sorry, I'm on. So yeah. Is it any better? Can you hear me now?
I can hear you much better now.
Yeah.
You want to re-say that again?
Yes. Sorry, I'm on my phone. I put in the chat EV board, and it's listing 8 criteria that we think electric vehicles can meet around the sustainability for the materials that go in them. We believe that gas vehicles have no chance, but for EVs, this criteria is very tough, especially for the mining and refining industry. But we think by working together, it should be possible. And ultimately, our goal is to create a consumer brand where this will be recognized for cars and batteries that do meet all 8 of these goals. That's our long-term aspiration.
Maybe turn off your video because the bandwidth is so bad. That was also then hard to hear.
Let me see if I captured this, okay? And see. So the 8 criteria for betterev.org. If you look at those criteria and use those in the spirit of really the development of an electric vehicle, that this effectively, I shouldn't say assures, but definitively, quantitatively will demonstrate a significant benefit over other pathways for electric vehicles or other vehicles. It'll give you the most fruitful direction. And I think it'd be worthwhile to look deeper into that and see what it says, because it might give some good thoughts in terms of best practices and where policy should go. Antonio, your hand's raised. You want to say something?
Curious about, in terms of sustainability, the change that will happen in the supply chain from ICE compared to lithium processing. So you're getting petroleum processing, shipping. It's going to be a worldwide industry that's going to be changing. Lithium can be a lot more localized due to its abundance pretty much everywhere, but like rare materials, nickel, cobalt, those are still going to be kind of isolated. But that also causes a sustainability shift in power on a global scale. So people like Indonesia is going to be rising in power, whereas United Arab Emirates and Saudi Arabia will be falling in power. So those will be changes as well.
It's a really good point, is that and this is at the raw material basis of where the supplies are. And that becomes, one of the big points about how the raw material suppliers will move. And I think we see it already with not just the raw materials, but then the next stage, which is the refinement and the political fallout that's currently underway in that area. We're all familiar with the fact that where we are with batteries today, when we talk about particularly the critical minerals, which by the way is my next slide, I might as well bring it up since that was a good topic. Critical minerals, when we look at this, the refinement of them is overwhelmingly right now in the People's Republic of China. And there's a great push by many regions around the world to diversify that. Now that's where we are today, but it doesn't solve the problem of the power shift with raw materials, although politically speaking, there's a lot of movement there too. And the idea of being able to diversify that to some extent, or at least to provide, how should I say, further international protection over the regions which will have to supply that. You know, I didn't even mention the recycling again yet. I'll like, you know, in detail. I've sort of said that's a whole topic on itself, but you can't help but to think about what does a mature recycling loop look like? Because we're at the point of right now, as we all know, where we're having this massive growth in the consumption, the usage, the need. And that's going to continue to outstrip anything for quite some time. So we're still putting material on board. At some point in time, there'll be a substantial amount of recycled material, but the question is by how much. And I know that there's regulations, particularly in Europe and in Quebec, where they're looking at starting to set for percentages. They may not necessarily be aligned with what I just described, though, the rate of the demand growth, but locally they may be capable. So there are potential ways to do this, you know, to enact a requirement for a certain amount of recycled materials. And then the question is, which materials are they? Critical mineral for EV is most probably copper. Well, copper will be in almost all batteries, so that's an interesting point. You know what was interesting is that copper did not make the critical mineral list. At least in the United States, it didn't make the critical mineral list. That was the fun one. I was looking for that. The ones I showed here, they all made the list. So I thought that was an interesting tidbit to think about.
Is that a potentially interesting one? Because hypothetically, if we go from lithium to sodium, we're still using boatloads of copper, and there's still boatloads of copper which we can recover.
I think that's the point, is that we have a very well-established industry with regards to recovery of copper. So perhaps that's the reason why it was not on here. But if we think about the sheer volume and the displacement of from other industries of copper to this industry, that in and of itself could lead to a pretty interesting problem.
But, you know, one thing I think people forget already in the United States, and I can quote exactly, cobalt, because of its value, is already recycled.
Yes.
Quite a bit. And we use 29% of cobalt consumption in the United States was obtained from scrap. So when people don't think recycling is happening, it is. Might not be recycling of batteries, but it's recycling of other things that contain cobalt. So just a thought.
Thought it was interesting. There's a startup spin out Gray. They're looking at recycling nickel from cells, but not into cells. They're looking to get it to a good enough grade that it can then be supplied to the aerospace industry, who have no interest in making, for now, these cells. So yeah, people are capturing value out of these high value materials, but it's not necessarily staying within the automotive value chain.
And it's always been the case. I mean, if you look at very high nickel content stainless steels, engine exhaust valves all have very, very high portions